Hello and welcome to this week's Maker Meeting from Workshop 88. Each week we explore projects that our members are working on. We are members of a community makerspace primarily serving the western Chicago suburbs. We're always striving to build and grow our community of makers. We believe that we become better makers by learning with and sharing with others. We hope you enjoy watching our meeting and we invite you to become involved with us no matter where you live. This week we are going to have an update that I'm pretty excited to hear about. I'm going to stop sharing my screen and we're going to be hearing from Phil, who's been pursuing these weather balloon radiosondes for a while now that we've heard about previously. And Phil has a big update for us. So I don't want to say anything more. I'm going to turn it over to Phil.
Okay, thanks, Andrew, for the introduction. So I went out on my second attempt recently to retrieve or it wasn't really with the expectation of retrieving a radiosonde, mostly just to test my setup. And there's a forecasting tool, which I've talked about before. Let's see, that's you can predict, you enter in some numbers here. There's the default values here, but the important thing to customize is the latitude, longitude.
Are you thinking you're sharing your screen?
Do that every time. Okay. So here's the site where you can get a prediction of where one's going to land. This particular prediction on the screen right now is for this coming Sunday. But on my second attempt, like I said, so you put in the time and the date, and most of the other things you can go with the defaults. They're pretty good. And then the latitude and longitude of the launch site. And so for the second attempt, it was going to land west of Elgin. And somewhere out in the rural area was the predicted site. And the short version is, so I went up there, and I still had some things wrong with my setup in that I had to reposition the antenna in my car. I had to deal with some various computer problems with this. I can't even remember all the things. It seemed like everything went wrong. The first attempt I had talked about before, where everything seemed to be right, it was almost like beginner's luck. In this second attempt, everything went wrong. And one of the big things that got wrong, so the prediction was that it would land over here in the rural area just west of Elgin. But then when I got to, let's see, I don't remember exactly where it is on the map, but there is a Elgin Community College around here somewhere. And so I went into their parking lot to wait. And what ended up happening was the prediction was pretty way off. It ended up going much farther east. Last time I had looked at it, it was going to land in Palatine. And so I had to start moving towards Palatine. Well, since I have my antenna mounted on the windshield, as I pointed my car away from the balloon, I ended up losing the signal of the balloon. And that combined with the fact that I was getting into mostly residential areas, for a while it looked like it might have ended up in one of the forest preserves or something. I was getting more and more residential, and I lost track of the radiosonde, so I gave up and came back home. But the thing was, I didn't really expect to retrieve it right at that time anyway. I was just trying to test things. So then I started doing a forecast for another one, looking ahead in the forecasts. And let's see, there was, so this forecast came up. We're in Google Earth right now. A couple things too that I had done in the meantime was one, on my base station, I had improved my antenna a little bit. I also added an amplifier which is nice just because then I get a better sense of what happens when these things take off and I get a little bit closer to the actual landing site, even though I'm only following from home. But I did eventually figure out the exact spot where they launched from. And this helps because it makes the predictions a little bit more accurate. So this little building here is, oh, it doesn't show up. This is the NOAA station in Davenport, Iowa. And this is, I know this building is where they launched from because, oh, this one's actually marked as balloon launch. I didn't put that, but I don't know. Anyway, so this is where, from photos and whatnot, I figure out this building is where they launched the balloons from. So that pretty much nailed down.
Why does the why does the track start from like a little bit north of that building?
Because there's a little discrepancy on altitude.
Oh, okay.
So this is, I don't know. That's another thing I'm trying to work on. So I don't know if I have on the prediction for the forecast, I have launch altitude 0. I should probably actually put the elevation of the launch site in there, and that might help a little bit. But still trying to figure out that. I did figure out that in Google Earth, you have to go through a couple steps, but the Radiosondes GPS data, in order to get it to scale appropriately for altitude, there's a couple things in there you got to go through and check. And it's more than one step, but eventually you can get it to the altitude to scale exactly, so that and you can see. So these are the rural roads out here. This grid that you see is the rural roads, and they're about a mile apart from each other. And so this is to scale. So the balloon pops at roughly 30,000 meters. And so that's, oh shoot, I don't remember how many miles that is, but it's way up there. I don't know if you've ever seen one of these videos on YouTube where someone launches a weather balloon with a camera, and by the time it gets up to where it bursts, the sky is black. Some people say it's edge of space. I wouldn't go that far because, well, edge of space isn't exactly a hard boundary anyway. But anyway, my point is that they go really high. So here was the forecast, and this was predicted landing sites. And based on my previous experience, I knew that perhaps trying to be downwind of it might not be the best spot to wait. And so I actually planned. What I ended up doing, that forecasting tool, I did plus or minus 2,000 meters and plus or minus 2 hours, and I ended up getting this area. I don't know. That might sound like an obsessive amount of effort, but it only took a few minutes. And I made this little polygon area on Google Earth, and I gave just to get a rough idea of some very expand upon, instead of counting on this predicted spot, to get more of an area. And so conveniently enough, I ended up going to Gardner, which is just a little bit north of there. This is right off of one of the interstate highways, I-55. And so I stopped. This planning, I think planning makes a big difference. So with the satellite images, you can then zoom in and say, oh, okay, this looks like a good place to stop. Turns out this is a BP gas station. And so I set my GPS for directions in my car to the BP in Gardner, Illinois, and I got nice directions to here. And then from there, I had a good spot to reorient myself, see where the balloon is going, and make any changes, check my tracking system, see everything's working okay before I start moving around trying to actually chase after the thing. So with that plan in mind, I went there. I did end up on my way there, since I was going, let's see, I-55. So I'm coming from Naperville, so I'm going almost due south most of the way. What I ended up doing was moving my antenna. I normally have it up in the windshield. I moved it over to the passenger window. And let's see. So this was the forecasted path. And this is what my base station ended up tracking. Let me overlay the two. So this is recording from home, and from home it actually went in pretty close to, pretty close to down to the ground. I'm still surprised by that I get a signal that low on the horizon. And then let's see. So from the car in green here, this is where it started picking up. It had, as I was driving, it started picking up further west here, and then I'm not sure exactly at which point I had repositioned the antenna. Once I got to the BP station, I stopped, and I remembered also from my experience with up in Elgin that the problem with the antenna mounted in the windshield. So I have a sunroof. I normally crack it open to put the GPS antenna up on the roof. And like, well, at this point, I'm just going to be on rural roads anyway. It was, let's see, this was early on a Sunday morning. I mean, let's see, 5:15 a.m. was the time that the balloon went up into the air. And by the time I picked it up, it was about 8 a.m. on Sunday morning. So, you know, there's on rural roads that time and day, there's no one out there. So I figured, well, I don't have to go on highway speeds. There's no one around. I don't have to worry about the antenna flying off. So I opened up the sunroof all the way and used the suction cup mount and put it up on the glass of the sunroof. And then, so then I did not have any problem with direction. It was made my antenna more omnidirectional. And so I was able to track it the entire time without, didn't matter which way the windshield was facing. And so this worked out really well. And so let's see. Let's see here. I'm going to show some screenshots from the tracking software in a second. But so basically, it landed in this middle of this field. I ended up being parked on the other side of the road, and had to walk 600 feet to pick it up from the open field. Couldn't be easier. But again, this goes back to the idea of planning ahead, thinking ahead, planning ahead. When I saw in the forecast that it was likely going, and initially when I started looking on this for this launch, the Sunday morning launch, it was showing it possibly landing like next to the Braidwood power plant, or there was another forecast where it was going to end up in the pond for LaSalle. And like, those aren't good spots. Then there was this other place. There is this place here. That's a square mile, and that square mile there is all private property. It's fenced off. It's some sort of club or camping or something like that. And all these places that were not too well, would have been a bad place for the thing to land. But then it started looking like it was going to land quite likely in a field, and so I kind of figured I would go ahead and make an actual try. I was actually on this one. I was determined to actually try to pick it up, and it went pretty well. So let's see.
By the way, I have coworkers that are members of that club, so you could have gotten in there.
Oh, okay. So,
So, Phil, on the map, it had actual landing. Is there something that you did that made it show up as actual landing?
oh, I put that bed in there after the fact. So that those were the actual GPS coordinates I had tracked it to. So
But
I went.
is that your data or is that the
That's
data for all?
my
Okay.
data.
So it's not helpful to them to share the actual landing?
Well, no, they so they predict, and then actually they do. So when you're uploading your data to their website, they're using that data to perhaps improve their predictions. The problem you have with most of these is that if you go, it's interesting thing, or I find it curious. Well, it's not without reason. So this is actually let's see, this is current right now. Let's see, so this is in real time. This was the most recent launch. Earlier, it was showing prediction of landing close to Morris, Illinois, and then eventually the prediction is here. This happens to be my base station tracking it up to 14 minutes ago. And anyway, but if the thing I wanted to show you is so there's only so here's this is the situation for this particular software in the United States. You only have these stations. The software was developed in Australia and specifically Adelaide. And look how many just around that city they have. And then New Zealand's got a few. But look over here in Europe is crazy. I've got a ton of these, especially here. Where's this? Belgium and Netherlands. A ton of them. So one of the reasons for that is that in the U.S., a lot of the stations are currently using the Radiosonde that's made by Lockheed Martin, and it's on its way out. It's they have had purchased so many of these. They still have some, so they're still using them. But what I was reading is that within the next couple of years, they're going to get phased out and probably go with a different manufacturer. And so they didn't have the code that these transmitters emit. The code is proprietary, and someone had to reverse engineer the code to get the data, and that took some time. So it wasn't until summer of last year, I guess, that they had started decoding the LMS6 Radiosondes. But answer your question, you know, why do they not show the final spot? Because so here, there's only so many in the Chicago area. The only ones really tracking the launches from Davenport. You've got this one in Dixon. You've got me in Naperville, this other one in Wheaton. There's another one that's shown right now, but it's in Frankfurt. And I don't think any of us has a good view. A lot of times I get pretty close to the horizon. Let's see, in this case, I got down to 0.2 degrees. That's pretty much like at the horizon. And so the altitude at that point was of the balloon was 825 meters. So if your antenna is not that good, you're going to lose the signal at maybe 5 degrees elevation or 2 degrees elevation, and it'll still be pretty high up. And so no one will know where it actually landed. Did that answer your question? In a roundabout way?
In a roundabout way, I just wanted to know if it was your data that marked it, and it was, and if you shared it and you end up sharing it by uploading and them having access to your data.
Yes. Yeah. So my data gets uploaded, and they can use my data. And they actually like that. They say that they could use that to help improve their predictions. So these are some screenshots. from me out in the field. So my station at home is on runs on a Raspberry Pi, and since I had that already set up and working, I just copied the image of that, made a second SD card, put it in a second Raspberry Pi because it was easy. And then since I have that Raspberry Pi running headless, I used my car happens to have Wi-Fi, and so I can connect with my laptop to the Raspberry Pi. I could have this just running directly on my laptop, but it was easy to set up this way. So these are screenshots from my laptop, connect with my Raspberry Pi serving the web pages. And so here I am at the gas station in Gardner. These red rings are spaced 1 mile apart. And this was you can see that there's about an hour before the predicted landing. And this was the predicted landing site at that moment. Let's see, then here there's about a half hour left. And I had repositioned myself. Gardner is up here. I came down south, and I had moved a little bit on the way there. And this was also very nice compared to previous outings where it was after sunset. This one was in the morning, so it was dark when I left home. But by the time I got to Gardner, it was the sun was starting to come up. It was getting light out, so it was easy to see. On these rural roads, and there's no one around, so it's really easy to stop, check, see what I was doing, reposition myself if necessary.
Hey, were those actually like windmills in the area in the map?
Yeah, those mark locations of windmills. This is these are some wind farms in the area. Yeah. This is the data for the this map data is from OpenStreetMap, and it's got a lot of interesting details, some topographic features, the wind farms, like you noticed, railroads, all sorts of interesting stuff. And it's nice to have those things. I like it because before I get there, I know what's going to be there, kind of, sort of, or at least an idea.
So, and then also, just remind me, where you said you made the copy of your Raspberry Pi that's at your home, and like, so that was in the car with you, but how does the you have your GPS in your car, and what's that connected to that's reporting back, that's putting it on the map?
Right, so I use the GPS for my car just for me to navigate, but this separately, the Raspberry Pi, I bought a GPS dongle, plugs in via USB, and it plugs in USB. It has a cable, so you can stick it up outside your car to get a better reception. And so that it's and then there's open source software. This was something I mentioned before, but yeah, it's kind of like when you're setting it up. It's okay. Here's the initial chunk of software. Download and get this up and running. And oh, if you want GPS, well, yeah, here's go to this other GitHub and then get the GPS thing. And then oh, if you want map data in case you don't have a cell signal, here's where you can go how to get offline map data stored locally on your Pi, so on and so forth. But so yeah, separate GPS antenna for the Raspberry Pi, and then and so basically I have the RTL software defined radio dongle plugged in and the GPS dongle plugged in, and then I have some map data saved to the Raspberry Pi. And it's good that I have that because once you get out past away from the highway, you lose cell signal pretty easily. So here I am, and there's about a half hour left. At this point, I'm like kind of like sitting and waiting on the side of a road, waiting for things to update. And things do change. Let's see, where was I? I was here, ended up moving over a couple miles. but we're actually close to where the final spot is. The final spot ended up being over here. And so as that changed, I quickly went over here, came over here. Then I saw that, oh no, it's going to be back there. I had to turn around. Turn around, and I stop on the side of the road. And now you see this one's in yellow. So this is a paved road where this one's gravel. And so it so happened, even though it was still pretty early, someone drove by and saw me stopped on the side of the road, stopped and asked if I needed help. I'm like, no, I'm okay. I'm just a nerd. But so then it was, I wish I had recorded this. I did not get it. I was kind of excited, and I had my phone out to try to record it. I wanted to get a photo or video of it coming down. I saw it, and it was so exciting to actually see. It, it's like, and so much anticipation. You're waiting, and then it wasn't until like the last couple 100 feet that I looked out and I saw the orange parachute. And then so this photo was this is from like about halfway walking from the road. It's about 200 yards from the road, and this is since I saw it landing, and the parachute is a nice bright orange. It was super easy to find. In the future, I am working on putting together a setup for radio direction finding in case it lands in, let's say it was summer, and for some reason I decided to go in the peak of the corn season when all the corn is 8 feet tall. So I want to have the radio gear so I can locate it with radio. But here was so easy because I could see it. I just walked towards it. Here's the parachute. Parachute is oh, it's not going to show up with my. It's about 4 feet in diameter. And there's this string. I don't know how well you can see that on your screen, but maybe you can follow along if I go with my cursor. The Radiosondes out off the edge of the photo here. I ended up estimating just by stringing it out with my arm, assuming this is 3 feet, about 80 feet of string from the balloon to the radiosonde. I don't know why they have quite so much, but here's the orange parachute, which is plastic. This is a remnant of the balloon, which is latex. Once it gets up to, the burst altitude, it literally bursts, and in some cases, I don't have an image handy, but if you go and search weather balloon burst, you'll probably find some images on Google image search, and it really does kind of like explode into a bunch of different pieces. So sometimes you might get a very large fragment of the balloon. You might even get the whole balloon, maybe, but in this case, I got just a very small fragment. I don't know how. This is all I got, just a little piece. This tag is also interesting. I don't have a photo of it. But, a warning, because they typically use hydrogen to fill the balloons rather than helium. Helium is very expensive, and NOAA, being a scientific organization, they respect the fact that helium is in short supply, and there are many other scientific uses for helium, so don't waste it on balloons. So there's a little warning on here that if the balloon's inflated, please back away because, well, it's full of hydrogen. So anyway, several tens of feet away, followed the string, and I got to here's the radiosonde. This is the antenna. This here is, I later figured out this is the humidity sensor. And let's see, is this, that's it for here. And I took, once I got, and at that point I was really excited, but I had gotten up really early, and so I kind of just wanted to go home. So once I got home, though, I took some pictures of the radiosonde in better detail. Again, the antenna. This is the humidity sensor. There's a separate sensor for temperature. There ends up being two different temperature sensors because here's another. They're thermistors, and this one is just for the humidifier because the humidifier sensor. I didn't know this at the time. I found a data sheet afterwards, and it's temperature dependent, and so you need to know the temperature if you want to get accurate readings of the humidity. I don't know if you can see that the temperature sensor comes off at an angle here, whereas the humidity is straight off. I'm not entirely sure why they have, I mean, I know they have the second temperature sensor because of the humidity sensor, but why they need, again, a first temperature sensor just for temperature, I'm not exactly sure. I can speculate, but here it is. This is probably bent up from the landing. All four sides have this thing about being a harmless weather instrument. Which I think is kind of funny in a way because the balloon itself has a label that says it's dangerous because it might be full of hydrogen. Here it is, LMS6 radiosonde, another sticker about where it came from. And here's the bottom. So right before flight, they connect the battery and they can set the frequency. There's a dip switch and they flip the switches, and depending on how you flip the switches, you get whatever frequency you want to transmit on. Here's the dip switch. Here's the connections for the battery. And then after I got home, it was still transmitting. It didn't even occur to me to disconnect the battery. And so I let it run for a while just to see how long the batteries would last. And after several hours, I'm like, okay, well, several hours, good enough. I'm not going to wait any longer. Disconnected, started opening it up. It's pretty well sealed with hot glue. And so I kind of went around and I didn't know exactly what would be on the inside. So I basically tried to cut along the glue seams, hoping not to damage whatever might be inside. And then the electronics on the inside, it's kind of interesting stuff here. So you've got this is the antenna. These are the sensors coming off over there. These are the connections for the battery. This is the GPS circuit. This is the microcontroller. There's some other chips supporting the microcontroller. This is just a voltage regulator. This is a counter, and I'm not entirely sure how that plays into it. I think it might have something to do with how the humidity sensor works. I still need to spend some time figuring that out. Just another view. There's also this edge connector, which is nice because I think I could probably use that to connect to like the microcontroller and other things. To try to maybe reverse engineer some of the stuff. So they do have right now on the website. You do get GPS data, the location data, the latitude and longitude, the altitude, but no one has figured out the sensor data yet. No one's decoded that yet. So you won't get any data for the temperature or humidity. So I hope maybe I can, now that I have one of these, I can play around with it and maybe try to figure it out. Let's see, there's, so this is the microcontroller. It's an ST microcontroller, 8-bit with 32K of flash and 1K of RAM. This is just a voltage regulator. There are 4 different places to connect a sensor. So there's sense 3, sense 2, sense 4. Sense 1 is somewhere else. I'll get to that in a second. But these are just the analog sensors. This is sense 1, which is interesting in that it has 7 pins. So I don't know if that would be for like a sensor module that would plug in. Analog multiplexer for collecting sensor data, I guess. This off in the corner here is a counter, and did I say this already? I think it has something to do with the way they measure the humidity. This is the GPS unit in there. There is a data sheet available for this. This is the radio transmitter circuit and the IC. I was able to get it, figure out what the chip on that. It's made by Texas Instruments, and it is obsolete. If you look it up, it'll say don't use for any new designs. Interestingly, it can be reconfigured. There is free software available from Texas Instruments. Unfortunately, you've got to have a legitimate Texas Instrument account. They don't like Gmail addresses or Yahoo email addresses. They want you to have a legitimate corporate email address. I won't use my work email address because they're very serious about ethics where I work. So I don't know. So that's what's inside. And I'm very excited about that event. I'm also excited about trying to get a second one, at least a second one, maybe a third. I don't know how many I would. At some point, I'm sure the novelty wears off. But there's the other thing too is you can see over here on the side. There's 3 of these lithium batteries. Not that really makes up for the amount of time and effort that went into finding this, but if I could repurpose the board and I don't know, I mean, the cool thing is that, so you've got this microcontroller that you could potentially reprogram. If I could manage to get a copy of the software somehow, then I could reconfigure the frequency that it transmits on. The radio IC is covers a very wide range of frequencies, but you have to configure it. So
and you can run your weather balloon.
Exactly. Actually, as I was reading about some of this stuff, well, let's see if we have. Oh, here we go. I don't know if you can see this. You get this error message. They about error uploading, and they had HabHub is currently under heavy load. Well, so this website was originally intended just for amateur balloons. But after so many people started setting up their own stations to record radiosondes, now they're getting flooded with data from the regular weather service radiosondes. So they had to throttle the incoming data. Yeah, so this website was originally set up for amateur balloons. But it would also be cool for, I don't know, since you already have the temperature humidity sensor on there, maybe do your own personal weather station with it, or yeah, your own weather balloon. Anyway, pretty neat stuff. I'm looking forward to trying again, maybe on Sunday, this coming Sunday. Forecast looks good. It's another out in the middle of the rural area situation. So let's see. So, but yeah, I guess the key to success is really just putting some time into thinking ahead. and being ready to. Other thing too is just, once I get to my weight location, I can check all my stuff, make sure everything's working properly. And then after that, it was easy. I pulled up to the spot, pulled over onto the side of the road and waited, and then it showed up. Walk over, pick it up, go home. So a lot of fun. Got any questions?
Yeah, that's awesome. Can you let's have you like unshare your screen and then we can have a quick discussion.
Yeah, sure.
So my question was, I guess I got a couple of questions. One is, how are they able to predict the like 5 days in advance the possible track? Like, that's purely based on weather data that's existing?
There is there's a global forecast system, GFS, and I can give you a link. I'll give you a link on Slack. I think actually Danielle posted this recently. It shows the wind data at multiple levels around the world. This is something that's done by the U.S. National Weather Service, but the contributors are from around the world. And so that data is also publicly available, and they use that data to do the predictions. And so when I go out and do the tracking, let's see, nope, not there. So like here, I'm not using their data. This is at this point I have already downloaded that forecast data, and so I'm
Share again.
It's been done locally. Oops.
Everybody take a drink.
There we go. So here I'm in my car and I don't even have a data connection at this point. The prediction is being done locally on the Raspberry Pi, and that's because that's one of the initial things before. So part of my process is get everything into the car, hook everything up, start up the car back out of the driveway, and then pull down a few houses away, and then power everything up. Then it connects to the Wi-Fi on my car. I connect the laptop to the Raspberry Pi, check everything. And the Raspberry Pi is doing its own predictions.
Okay, so my other question was, how are you powering the Pi? Are you powering it from your laptop? Or are you powering it from the car, or is it on battery?
I use a power bank, that you would use to recharge your phone or whatever. I did see on the first time I was out, I did not have the Wi-Fi set up in my car. I think you could also, there's other one, you could just set it up on your laptop directly. But one of the things that'd be kind of cool is if you're working with, if you have other people coming along for the ride, if your car doesn't have Wi-Fi, you can set up your Pi as an access point, and then everybody else could follow along with their own tablet or smartphone or whatever. But yeah, I use a power bank. Just the first time I was out, I didn't have my laptop set up, and so I ended up having a little screen on there. And when I was looking at the desktop on Pi, it gave that little voltage symbol that was being underpowered. So it doesn't quite like the power bank, but it runs.
Very cool. All right, cool. Well, thank you so much for sharing that. That's been a 3-part series now on the saga of tracking down these radiosondes and retrieving them, and I'm super excited to see if there's any progress on decoding the the control board, and where we can go from there. So thank you so much. So next tonight, we're going to hear from Jim, who I believe has something related to USB power. Is that right?
Yeah, this was actually inspired by Scott, who couldn't make it tonight. He had a nice bench power supply that lost a segment in its LED display, and then it occurred to me that I had something similar. So what this is, let me show you the actual device, the device in question. So this is it's just a USB power place that I can plug in to charge, headphones or something, but it's instrumented, and so that's the instrumentation is kind of the interesting part. So the whole thing started with one of these. So this is just I don't know, $3 Chinese series USB connection. It's just, male and female, and there's not very much to it, but it does have a display, and it alternates between current and voltage. Well, that's kind of cool, and I had wanted something on the bench so I could power stuff. I've got a, I don't know, 7-port USB 3 hub. The computer is way over there, but I wanted just power, and I wanted to be able to see it. So let's see if I can show some pictures. And so this is what's in the charger doctor. There's really nothing there. The USB connectors have been taken off at this point, and here is the shunt resistor, so it can measure the current, and I don't know, some dedicated chip to do this. And these pins are the display. It's a 4-digit 7-segment display. So I had some old cutout from a USB, I don't know, a USB add-in card for a PC, or a front panel thing maybe, and thought, oh, that'll be nice. So here are the kind of raw parts. Obviously the wiring had been done somehow, and this is now I needed to put it, somehow on my bench. And as with any homemade product, there's little wedges that you have to put in and stuff to make it all fit. So it looks like I had epoxied the thing to like a strip of acrylic, and you can see the acrylic on the top is pretty scored up. That's to give it some tooth so that it can be mounted on the bench. And the whole thing's powered just by a, I don't know, 2 amp or something wall wart. So it's got some power. No smarts. It doesn't negotiate anything. It's just straight 5 volts through this charger doctor instrumentation and out the ports. And it has 2 displays. It just cycles back and forth between voltage and how much current the device is drawing. So I thought, oh, this is cool. And the whole thing is just mounted under the edge of my bench. So this is cool, and I'm done, and and it just sits there and works. It's just on 24/7. I can always plug something in, and that was fine, and it worked. until it didn't work anymore. And the problem was, and this is what Scott had seen as well, that one segment of his display had gone out. And I went through and looked, and I think even if you're just using the digits 0 through 9, not counting any hex or any other alpha characters, there are four of the segments that will produce an ambiguous display. For example, you can't tell the difference between like an 8 and a 6 if one particular segment goes out. So I don't remember what segment went out. Okay, well, it's just an LED, and let me order another one, and I'll put it on. So I ordered some, and this was a while ago, and I ordered the parts from China, and ordered 5 of them, and so I got the parts. Well, the problem was not only that they were too big, but the multiplexing of this, the segments go, all the LEDs anodes are connected to the segment part and the cathodes to the digit part, or the other way around. And not only is this the wrong size, so it's not going to go in very well, but it's inverted. This one is digits or digits are anodes, and this one's digits or cathodes, or the other way around. So so I ordered some more, and actually got the correct ones this time. And just kind of looking at these, this is junk Chinese parts, and they're not very reliable. And so I was concerned about that, and I didn't want my good thing to fail again from infant mortality. So I wanted to burn these things in. So I made up a circuit board just to do this. So I had 5 displays, and all the segments are in parallel for each display, and then each whole display, all of them were in series. So I don't know, each one of them looked like an LED, 2 volts or something, and 5 of them. So this whole thing was maybe 10 volts. And this picture was, I think, partway through. At least one segment in each of these 2 displays had shorted, and that shorts, of course, everything. So essentially all the LEDs were in parallel. And I think maybe even out of the box, I was missing one segment, and I burned the thing in for, I don't know, I don't remember how long it was, 6 weeks, something like that. This is just sitting off in a corner, full brightness, just burning in, because I wanted to get rid of infant mortality. And I lost a couple more segments, and eventually got at least one that was okay. And so it was just kind of interesting to see Scott's problem when he had lost a segment and then couldn't tell what his meter was reading. And yeah, I've been there and done that and replaced the damn LED. And in fact, I don't know, it's been running for, I don't know how long it's been there, 5 years, I suppose. And by having gotten rid of the infant mortality problem, it's still running just fine. So the kind of the takeaway is, for these little cheapy things, for a couple of bucks, you can make an instrumented, which means looking at the current. That's the interesting part. Socket on your bench, so you can actually tell, well, is this thing even trying to charge, or is it fading? Is the charge almost done and it's down to nothing? They're not very accurate, but it's a lot better than nothing. So that's what I have to say.
Cool. I'm gonna try to Oh man. Oh yeah, here. Okay, cool. I have questions. So, first of all, is infant mortality, as you put it, is this a technical term or is this a Jim Williams term?
That's a technical term. We can take a little poll of the people here because there's a bunch of weird techie people and see if anybody else has ever heard of infant mortality for device failures.
That's a very common term in reliabilities, any kind of reliability context.
Okay. I mean, I'll just
No, it's not my fault.
No, I'm just look, it's new to me, so I'll just throw that out there. I have heard of the concept. This is it's applied in lots of different fields, but I've heard of that just sometimes well, I guess the example that I've seen it in is the Saturn car brand that was supposed to be super reliable and went for hundreds of thousands of miles. I think I read case studies or whatever where it's like I think the branding or the marketing department just found the cars that happened to go that long and found the owners and then built a marketing campaign around that. But the basic idea was that sometimes it doesn't really matter what the device is, if it's a car or an electronics part or whatever. If it works and doesn't get worn out, it'll sometimes go just almost forever, it seems like. And the sort of the article I was reading was saying this might explain why some people who you wouldn't expect to have a incredibly long life just end up having a long life because they just everything works and doesn't.
They just got lucky.
Yeah, exactly. So okay, so the term infant mortality is applied to 7-segment LEDs. That's new to me, so I appreciate that. I do have I guess one other question, but it's more about it's just really about how you use the device, not how you fixed it or updated it or whatever. But like I saw the two USB inputs or whatever. But I guess what I'm curious about is not how it works, but in terms of the application, how you use it, measuring both current and voltage, really.
Well,
yeah.
The basically what it is just a USB charging port, if you want to call it that. So
Okay.
here's a USB female. It's always got 5 volts on it. If I want to charge, some device, the data lines don't go anywhere, so it doesn't talk to a computer or anything. And similarly, it doesn't do no stinking negotiation or anything. It's just 5 volts, as much as you can suck out of it. Typically, I'll use it exactly as a charging station, for charging my headphones or something. And the current notification will show me whether it's really charging. Now, if it's some commercial device, it's pretty obvious. If it's some cheap Chinese piece of junk and I don't know what it is, and I don't know whether it works, and I don't know nothing, if I can at least find out whether it's drawing some current, or if it's drawing 900 milliamps and it's the size of your thumb, that's probably not a good sign. So it's a general purpose test device if I'm powering something from 5 volts.
But you don't typically then take you don't have some sort of USB cable with the other end cut off and just bare leads that you're using to power you're not using it as a test bench power supply, or are you?
Oh, sure. Now I'm not going to be able to find one.
Because as a 5
sorry, I can't find. But yes, I certainly have USB cords that just have clip leads coming out,
Okay.
to power something that needs 5 volts.
5 volts. Okay, cool. Yeah.
So, and in fact, well, there's two benches. There's the computer bench and the electronics bench. They happen to be in different rooms. And this is the computer bench. And there's nice power supplies and stuff at the electronics bench. But just for Arduinos and stuff, 5 volts is pretty common stuff. And 12 volts is too. And so there is, that whatever 5-volt wall wart is powering this thing, and clip leads and stuff. So I have an easy 5 volts here at this bench. And there's also 12 volts coming out on a coax barrel connector and center plus. And that's, it's just there if I need 12 volts. And that's the barrel connector is my kind of standard thing. And there's, 6 different things that it ends up getting plugged in. And that same 12 volt supply is peeled off for an extra, light source, face light source. And there's another light under the bench because it's dark down under there and I've got to get the network connections. So there's an LED strip, just so I can see stuff. And that's also split off this 12 volt supply. So the convenience is having 5 volts and 12 volts, at this not really electronics bench.
So I guess I kind of missed, what exactly were your infant mortality statistics? How many of them failed during that burn-in period?
It kind of looked like, going back from some of my notes, and I don't remember, but I think I had 2 bad ones just out of the box. And I sent back to the eBay vendor and tried to negotiate something. I don't remember whether I got anything. I think I saw a note that one of them had a segment missing. And I think over time, I dropped another 3 segments or something.
That just seems really high to me. Like, usually you think of any kind of solid state electronics as being extremely reliable and almost never fails. And
well, sure, unless you're getting seconds from China. But I really didn't want it to fail again, because it really was just infant mortality. The one that the first one I put up, just, the display that came with that, $2 charger doctor. All the segments were lit. It was cool. It worked until it didn't. And then, I don't want to have that happen again.
Manufacturer of that $3 device must be buying the seconds.
Right.
So when does a 7-segment LED graduate into a toddler from being an infant?
Fine, clever question, Andrew. Next.
If you want to get into these gory details, I'm sure Jim could talk about the bathtub curve. that if you typically you either get early failures or they last forever until they start wearing out. And if you draw the curve, you can eyeball or mathematically figure out when you start to get down to the bottom of the curve and figure that you've got most of your infant mortality out of the way.
Yep. But infant mortality, when things fail early on, whatever the cars or electronics or, infants.
Very cool. So this is actually not a bad segue, I think, into maybe our open discussion. And it reminds me of, I inadvertently discovered, I guess, I don't know if it's a tech hack or a life hack, but I inadvertently discovered a charging hack this morning. I've been dealing with a car battery that is getting old, and I really need to replace it. And it's the 12-volt battery on my Prius, which is now, I guess, 13 or 14 years old and just probably is near the end of its life. And with the cold weather, it dies and whatever. And I have a charger that I can use if I need to start it when it's been sitting for a couple of weeks or whatever. And so this morning, I discovered that it was so bad that the jump start mode on the charger wasn't enough to actually jump the car. And so I put it on the trickle charge mode, and I noticed that it was reading I think it was 4.4 volts to start, and I was like, wow, that's pretty low. That's no doubt about that. But I noticed that it was steadily climbing up, and as it was charging, and so I thought, okay, I'll just let it go, and I'll remember to come back in or come back out into the garage and check it periodically or whatever. And so I went inside, and I was actually making some Christmas treats sort of thing for the family and whatever. And my wife was watching TV, and so I decided to put my headphones on, and I was listening to some podcasts, and all of a sudden this is maybe an hour later, the podcast like went out on my phone, and I was like, well, that's weird because the phone says it's still playing, and so I like turned the volume up and I restarted the app or whatever, and nothing was happening. And I realized that the Bluetooth had kicked on because the car had charged, and then the charger had started the car, and so the car was running in the driveway, and the parking brake was on, and so the Bluetooth was on, and so it turned out that this was kind of a little inadvertent life hack to tell me, hey, the charging process that you forgot about is now done, and you can go out and
Very, very cleverly done.
I thought it was super clever. I was like, man, if I had thought of that, that would have been just amazing, and I'd probably brag about it at some point if I had thought of that. But yeah. So anyway, your story about your charger reminded me of that. So anyway.
Car started up.
What's that?
I'm surprised the car started on its
So
own.
yeah, I'll be honest, like, even though I've been using this it's a Black & Decker charger thing, and if we do another favorite tool segment, I should probably bring it, because this is something that it was a Christmas present probably, I don't know, 10 or 12 years ago when the car was new, and I had no need for it. And and this year, with the car sitting for a long time, as I've been working from home, and the car being that much older, it's suddenly become a favorite tool. But I'll admit, I don't actually know exactly how it works. I mean, it's designed for a internal combustion engine car, where it has this mode that appears to be, it puts a pretty heavy load on the battery, and then it does this countdown for 90 seconds, and at 90 seconds it somehow tries to make the car actually start, which I really don't know how it's doing that, but that's
Yeah,
what it.
I doubt that it tries to make the car start, but I could believe that it does a heavy boost to get the battery up, to maybe help a little bit, and then it will put out enough current. I assume this is a good sized device.
Yeah,
It'll
yeah.
put out enough current to run the starter, to be willing to run the starter motor, for not for very long, it's
Right.
So I don't think it tries to start it. But I think it would let you try to start it. And I also don't have any idea why your Prius would have started that way.
Well, that's what I thought initially. And the very first time I used it, well, so what happens is, as soon as I attach it and plug it in, the headlights come on full brightness, because I leave my headlights in sort of the auto mode, and typically in that mode, it's enough to start it up. And this today it was not enough for me to start it. And so
I assume you left your keys in the car.
yes,
Yes.
yes,
Oh, well,
well,
then it's at least got a chance.
yes, yes.
It still almost seems like a safety hazard that the car can start without being asked to start by by the owner.
So, well, again, like, I don't know if that's actually what was going on. I let it run through its whole routine, and then it seemed to like try to do the jump start.
I think you're doing pretty well with your. Oh, I'll wait till you're done. You're doing pretty well with your Prius battery. We have well, my son now has the 2009 Prius, which is on its third battery basically. It's been replaced twice. He just replaced it this year for the second time. So,
Yeah, I'm finally at the point where I'm like, I think it's not just that it is sitting for extended amounts of times. I think it's really that the battery is on its last legs and needs to
well,
be.
here's how that battery. You can count
Yeah.
yourself lucky. You got one of you did not have infant mortality. You got one of the long ones.
Exactly
Yeah.
right. It got at least to the kindergarten stage, basically. Cool. So
I had
other items that people wanted to discuss, maybe, I don't know.
Oh, it
I
was,
did want to say welcome to Mace and thanks for joining us.
Yeah, thank you, Gail. Thanks for joining. And that's a good reminds me that I wanted to shout out to our Patreon supporters and encourage other people to support us on Patreon. So yeah, welcome Mace and first time with us on these maker meetings.
Thank you. Thank you. Glad to be here.
I found something that this was one of my very first laser cutter projects. I didn't even do it at Workshop 88. I did it at a different place, and it didn't quite work because I was overthinking things. But it reminds me I want to try it again. And it's I'll show you. It's two. They're not quite circles. They're ovals with little notches, and they're supposed to go together, which they do. But they don't interlock exactly. There's a little bit of wobble because I was overthinking the kerf of the laser cutter and I made it just a little too big. The tip here is just don't overthink it. Just, do it. Anyway, but the idea is that if you put these together and you set them on a table, they'll this thing will roll. It rolls and it really doesn't even matter. Well, I mean, it has to have some sort of roundness, but it doesn't have to be perfectly circular. It can be oval or whatever, and it will it rolls. And so I wanted to explore that, and I'm gonna go back and explore more of that. So but I found it, and it reminded me, hey, that was an idea I had a while back, and I want to get back into that.
yeah, there are various 2- and 3-dimensional shapes that that will behave, interestingly that way. I made I laser cut the parts for a demo that I haven't ever actually put together for a maker fair or something, with round wheels and maybe square wheels and some rounded triangles that roll nicely. And then there, you you watch YouTube, and there are people with lots of really interesting 3-dimensional shapes that have that same property, that essentially the center of gravity stays a constant distance away from the circumference when it's sitting on a table. So yeah, those are kind of cool.
I saw the square wheels at a science museum somewhere. I can't remember where it was, but square wheels on a special track that keeps the axle moving in a straight line.
And somebody had built a bicycle with square wheels, and shoot, oh yeah, the wheels didn't turn on an axle. The bike sat on top of rollers on top of the square wheels, and that somehow that was still, that's not enough by itself. I bet if anybody Googled square bicycle wheels, you would find a YouTube of this. It's pretty rough, but he could actually ride it, and was interesting.
Yeah, I've seen I haven't, well, I've seen the videos of bicycle displays in the museums of exactly what you're talking about, but the adding the extra thing of on top of rollers is not something I've seen. Although it reminds me a little bit of the attempt to do the virtual space, like the sort of the 3D cave type things that have where you can actually move. So like you can walk in it. It's almost like a two-dimensional treadmill. Yeah, something like that.
Okay, but he is using a non-flat surface to ride on. That's the same as the museum demonstration that I saw.
That's the key.
And I believe I remember seeing a Mythbusters episode where they just put some square wheels on a truck and brute forced it down the road.
Was somebody on it?
I think that it was a vehicle, a car or a truck, and I believe that the gist of it was that once it got up to speed, it would actually smooth out and become somewhat less bumpy. But that's been a while since I saw that episode.
Wow. Very cool.
Hey Jim, you got to do like a demo or something of your PCB etching. You make such lovely PCBs.
Yeah, I could do that. I could even, I don't know whether I can pull it off on a Tuesday night. I've been doing it for a long time, and I can I can tell you more than you want to know about it. And it's really, there are some parts are trickier than others. The etchant is certainly a part, because there's chemical problems with that, because copper salts are problematic. But there is an etchant that addresses that problem, where in fact cupric oxide, I think, is the etchant. And so all the copper that dissolves just goes back and makes the etchant stronger. It's really kind of an interesting life cycle. Yeah, let me think about trying to do that.
I'll second that motion. That sounds interesting to me. An interesting meeting.
Maybe we can kick off the new year with Jim etching something very cool for us as a demo.
So I've only tried to etch boards a few times myself, and it was less than satisfactory, I guess.
I recommend just sending your files to Jim. You're muted. You're muted.
Send him our Gerber files.
Okay, am I not muted this time?
Muted.
So this was one, and I usually will date things that I make. And so this was back in the days of using Sharpie as a resist. And, this was a new one. And this is dated 10/11, and this is dated 10/81. So these were 30 years apart. And the complexity has changed, and the technology and stuff. But it was just really pretty interesting to me to discover, geez, have I really been doing this for that long? And so I've gotten better.
That's pretty.
Were they both LM86 boards, or what was the other one?
No, one was a recording device, square dance recording device with an AGC and limiter thing, and the other one was probably trying to send sound on a light beam or something. I don't know what these physics teachers do.
Nobody really knows. Cool. I want to know what anybody's doing. Any projects going over the next couple of weeks for the holidays, either Christmas, New Year's, or are we looking ahead to I don't know, Valentine's Day, whatever the next cross quarter day is.
Cross quarter?
You're familiar with the cross quarter days, right? Like, no? Oh man. It's I don't know. It's something that astronomers sometimes talk about, which is, the major holidays sort of fall on the quarters, and then there seem to be sort of minor holidays that are kind of like halfway in between, like major holidays or whatever. So, like Halloween is kind of close to the fall equinox, and Christmas is near the solstice and things like that. So you have these quarter days and the cross quarter days or whatever. So I'm not an expert, but I think Valentine's Day roughly lines up with one of the cross quarter days. I could be wrong. Don't quote me on that.
Well, I certainly gotten burned. One of the classics was there's a poem, The Wonderful One-Horse Shay, and I thought everybody knew that. I grew up and I knew it, and I made reference to it. It worked. It was a completely relevant thing, and there were just a lot of blank stares. And I finally did a poll around work. There's a bunch of engineers, right? And I don't know, 20%, 15% of them had heard this poem. And so I've gotten a little more sensitive about mentioning things that I think, well, geez, everybody knows about this. Carve away everything that doesn't look like an elephant. And there's just lines that are completely obvious. Everybody must know this. And well, no, actually they don't. It's kind of a surprise sometimes.
I just stumbled across that poem in the last few months. and it's actually relevant because context was you may have heard of I think his name is Henry Petoskey or something like that. He writes about engineering, and he wrote a book, I believe it was called The Logic of Failure, and it was all about some of these things that we were just talking about, like reliability and why things fail, and step curves and infant mortality, and how the one-horse shay, everything fell apart at the same time.
So wait, the name of the poem is The One-Horse Shay?
The Wonderful One-Horse Shay.
Okay, I'm gonna have to look that up. I'm not familiar, but
Yeah, it's cool. The story and it's
Okay,
somebody, things fail. There's always some weakest link, and somebody designed a one-horse shay to have no weakest link, and everything was equally strong.
And whatever was weak, he'll make that a little bit stronger so that it'll last, so that it won't be the weak link. Yeah.
Right. And so there were no weak links. And so, 100 years to the day, the whole thing fell into dust or something.
interesting. There's
It's an interesting story.
It reminds me of there's a great XKCD comic about how every day somebody, there's like, if you do the math and you make a back of the envelope estimate, like every day there's probably a certain number of people you meet that have never seen the Diet Coke and Mentos demonstration, and instead of making fun of them, like you should be like, this is so great, this is your opportunity to like get to see this, and I get to be a part of like showing you this or whatever, and it kind of flips the typical like attitude that some people have of like, oh, I can't believe you don't know that or whatever, and I sometimes with my students especially, I used to feel old. I still feel old, but I used to feel real old when it we talk about movies that like shaped your childhood or whatever, and like for me that those movies were Star Wars, the original Star Wars, and very quickly as a teacher I discovered that there were students that had never seen Star Wars like at all, and like I can't relate to that as a thought, but like I have since come to terms with the idea that like every day, like literally every day, there are thousands and thousands and thousands of people who are born who have never seen Star Wars. And that's just something I have to accept. And I have to be a part of bringing them the joy of seeing Star Wars for the very first time. One of them might be over there.
We're glad you have a mission.
I do. Well, it keeps me going. It really does. But I love those. I love the Petrosky books. I have several of them on a shelf over there. I could go and grab. But yeah, cool. Gail,
Yes.
you had a topic.
Yes. So speaking of astronomy and stars, has anybody seen the Christmas star or gotten pictures of it? Or anybody want to explain what it is? Because I don't.
Okay, I will. Actually, I'll share later on Slack somebody who did a. I haven't watched it, so but somebody who did a Zoom presentation about the Christmas star just historically and astronomically, so whatever. But yeah, so there's a conjunction, which is the apparent lining up of two planets, Jupiter and Saturn in this case, and speaking of Phil's weather forecasts or whatever from days out, I typically don't trust weather forecasts for 3 or 4 days in advance, but 4 or 5 days ago, I looked at the weather forecast and I saw that Monday night was probably going to be cloudy according to what they say. And I've been doing astronomy long enough that I just figured that every night's going to be cloudy. And if I plan that every night's going to be cloudy, then there are some nights that I'm pleasantly surprised and I get to actually see things. But Sunday night, when I saw that it was not cloudy towards sunset, I dragged the telescope out of the garage, the one that I unbricked several weeks ago, or a month or two ago, I guess, and dragged it out. Oh, this ties right into my other story. Yeah. Okay, so I dragged it out to the end of the driveway. I backed the car up. I plugged the telescope into the the power adapter, the cigarette lighter that's not a cigarette lighter. And this telescope, which drives me crazy, always tries to find alignment stars, so it will just auto point it. And I just want to cancel that because I just want to point at the really bright planets that I happen to know exactly where they are, because I could see it, because they're literally the first things that were appearing at night. There's the moon, and then the first thing that looks like a star, that's actually the planets. But I spent 30 minutes trying to get this stupid telescope to stop aligning to stars that it couldn't see through all the trees or whatever. And I finally got it to do it. And so I pointed it at the thing and I saw it. It was really great. It was the Jupiter and Saturn were all in the view of the eyepiece. And I ran inside and got my wife and son to come out, and we looked at it. It was really neat. And we saw, we didn't take pictures. I'm sorry. I'm unfortunate. But it was a lot of fun. And then they went back inside and I dragged the telescope back in to the garage, and I put I wound the cord up and whatever and tossed it in the car. And then I hopped in the car, and that's when I discovered that running a telescope off a car with a really bad battery, that's a way to drain your battery. And so that's actually the origin of how the battery most recently died.
That's what I was going to ask you. What car you hooked that up to?
It was the one, yeah. And that was and it was funny because I used the charger and I usually do. I charged it and it got started, and so I moved it into its park position. But I knew I hadn't run it long enough for the alternator to sort of recharge the battery. And so this morning was when I was trying to restart it and found I had not. It was worse than I thought. So anyway, yeah. But that's funny that all tied together, and I didn't even really remember that until now.
Full circle of stories, Andrew.
Thank you for bringing that out. Anyone else check it out? See the two planets?
I have not.
Yeah, so they're gonna. I mean, they're gonna start moving further apart, but I mean, you'll sort of still be able to see them kind of close to each other. Um, I saw these really funny. I mean, this was talking about clouds and everything. Like it was cloudy last night, and it really bothered me that I woke up this morning and it was, uh, you know, no clouds this morning. So like last night, lots and lots of clouds. This morning, no clouds, and it's like the weather is just taunting amateur astronomers or whatever. But uh yeah, I saw a lot of graphics on online this past week of people just anticipating that they were going to be in between, or there were going to be clouds in between them and the planets. And yeah, definitely happened to a lot of people, but that was
Does it look
fun.
like one spot of light, or can you see, if you're just looking at it with your eye, does it look like two planets, or is it just one spot of light now?
Last night or Sunday night, it was one. It looked like one thing, and I was surprised. And it wasn't even. I mean, this is not even like Jupiter at its brightest. Um, I mean, it was definitely the brightest. Uh, well, yeah, it was the brightest star-like thing early in the evening. Um, but
Were you able to tell, did it look any brighter when they were in conjunction versus like the night before or the night after? Did the magnitudes add?
no, I don't know. I didn't see him the night before, so I can't personally say, and I haven't looked at the sort of the data or whatever. But that's a good question. I like how you're thinking, but I don't know. That's a really good question. So yeah.
I only have to wait like what, another 400 years or 800 years to find out.
I think it's actually only 60 or something, roughly speaking.
I heard 800, but that's just
Oh, you heard 800? Yeah, in 60 years, they're not going to be quite as close, but they are going to be kind of close. So
I didn't know either.
yeah, it may be several hundred years, but I mean, who's counting? I'm, I figure I got at least 2 or 3 more Halley's Comet orbits in me. So, optimistically speaking, right? I don't know. The one thing I do say about these rare events in astronomy, and I'm certainly not the first to say this, but rare events are themselves not rare, and it's like I wish that my specialty of science had the like marketing power of astronomy, because like you know a partial lunar eclipse happens and it makes it into like the New York Times or something, which is like super boring. Like a partial lunar eclipse is like
How about the number of times you see supermoon?
right, yeah. And it's like I nothing against that, because like if it gets people excited, that's cool. But like how do you capture that sort of excitement for other things? And I don't know. I don't have any really good answers for it, but it's amazing to me what the sort of the free press that astronomy seems to get, which is I mean, cool. The other branch of science that gets a lot of free press is uh, medical related fields, because I don't know, apparently a lot of people want to stay alive or something, so there's like a interest in that. So but,
Well, sometimes I wonder if like NASA would do better if they weren't in the public eye so much. I mean, there's other government-funded research that might go over budget or might have problems or whatever. Eventually, accomplishes its mission, and nobody ever really hears anything about it. And but something goes wrong at NASA, and then suddenly everybody's pissed, and oh, don't give them any more funding, and
oh, I tend to really agree. I think there's a lot of really interesting science that goes on in all different agencies, government funded or government funded adjacent or whatever. And yeah, it's something that I don't have great answers for it. I mean, there is something to an innate like wonder of the universe that I think a lot of us share. Um, but I don't know. I mean, like I'm really fascinated by alternative transportation type technologies, for example, research in that sort of thing. And the fact that the only type of press that sort of research gets comes from, essentially anything that Elon Musk spouts, which seems like half the time it's nonsense. And I don't know, it's just really troubling to me. And I'd be more interested in what people who have spent their lives and decades working on what they have to say. And I don't know. So it's a really I couldn't agree with you more, Phil, is what I'm really trying to say.
I want to see. I hate to keep. I feel like I'm beating a dead horse or something. But I've got this plot of this was on Thursday, and I saw this happen during our public meeting on Thursday, and I'll save it for some other time. But so this balloon was descending, or not balloon, radiosonde was descending on its parachute, and it got to a point. Sorry?
Are you trying to share a screen?
Not yet.
Okay.
So it got to a point as it was descending where the horizontal wind speed was fairly low. And so instead of having a nice gradual horizontal movement like you usually see, it starts doing this like corkscrew pattern.
Very cool.
Oh, wow.
That is interesting.
So you said it was on a very long string, right? Like a 10-foot string or something like that?
No, not 10 foot, like 80 foot.
Okay. So
And
that's what we're seeing here. Is it's probably spinning around the end.
yeah, this is probably swinging around, and yeah.
Oh, that's cool.
That is really cool. Let me ask: does your rig just automatically track, or do you have to like record? Like, do you have to intentionally connect to these things?
So it's set to the way I have my base station set up is that it scans. There's a known frequency range.
Yeah.
So it scans through those frequencies, looking for peaks, and it detects a peak, and then it'll analyze the peak and see if there's a little header. And then, okay, there's the header. I know I'm getting data on this frequency, and then it starts decoding the data. So I mean, that's how it works by default. I mean, you can set it, no, don't do that, just scan the one frequency. But yeah, basically detects the signal on its own and starts recording. It's really neat.
Yeah. That is.
If there's any pattern, like my first thought was that they would publish this information, and that's what you were linking up to. But you just scan and watch for it to pop up. Is there any rhyme or reason to the pattern they're using? Do they have, like, does Davenport always use the same frequency, or do they always use the same frequency on Monday, or anything?
Well, yeah, so I have noticed that not always, but typically Davenport does transmit on 401 megahertz. That's one of the options that you can select on the dip switches. So they typically transmit at 401. But not always. There's been at least 2, maybe 3 times where I picked up a different frequency. So that's why I keep my base station scanning all the frequencies.
They decide.
And but the timing is always regular. Basically all the balloons are supposed to be around the world are supposed to be launched at the same time, twice a day.
So like the exact same time or like same local time?
Same universal time.
Universal time. Okay.
So yeah, when they're launched, there's probably like hundreds of them in the air at a time.
Wow, that's awesome. Okay, so I'm curious about I guess like next week. We were planning to be on for next week. I assume that's still good.
We're not going anywhere.
That's what I was thinking.
Good for me.
Was my question.
Yep.
Yeah.
I expect you all to bring your New Year's drink recipes. You thought I was going to say resolution, but bring your favorite New Year's hacks or projects or what have you for that, and we'll talk about it, I'm sure, on Slack. But I was really, I mean, this was really cool. I'm so thrilled that there was this like arc to the Radiosonde story, and that was really cool. And Jim, I think like I'm gonna have to get links to these little USB things, and I'm not lucky enough to have a electronics bench and a computer bench, but I'll dare to dream someday that I can have that, and it does seem like a really cool tool to have, a handy tool.
There are lots cooler ones than that now. There's a bunch of USB power negotiation protocols, and the cool ones, I think Christine has one. They've got a much more sophisticated display, and they actually listen to the negotiations between the device and the host for how much power, and they'll display current, but they'll probably display power and a bunch of stuff. So they're much more sophisticated ones than these little cheap $2 or $3 ones, and those could be pretty useful.
Okay. Yeah, I'm interested in learning about those too. So that's very cool. So if that's if there's nothing else that we wanted to discuss this week, thank all of you for participating tonight, and again, a big thank you to all of our Patreon supporters and all of our YouTube subscribers. We're butting up against the point where you could round almost to 100, depending on how many significant figures you care about. But please subscribe to our YouTube channel, find us on Facebook, ring the bell. I don't know where the bell is, but I assume it's somewhere up there. And if you're in the area, if you're in the Chicagoland area, especially in the western suburbs, and you're interested in becoming a member of Workshop 88, we encourage you to reach out to us, and we still have the end of year / New Year special going on. So please find out about that from our blog and reach out to us. And we are welcoming a couple new members this week, and I'm really excited about that. And we have, for those of you that are nearby, we are open for members only. So you can work on your projects at Workshop 88 and join us in our Slack group and join us here on these Tuesday night meetings. So thank you all, and we will see you next time.
Merry Christmas all, and see you